Hey everybody. Let's see, so this is going to be a video, just hopefully it's a fairly quick video on how we can actually use the inverse trig function. So I just got done making a video of like deriving them and looking at the graphs. That's kind of what's at the top of the paper there. But the really important part about using trig functions, or the really important part of inverse trig functions, is how to kind of use them to solve problems. So I have here two problems that on surface, like at a first glance, they might actually look like the same problem, but they're not, even though they're saying very similar things. So one is saying, suppose that we wanted to solve this problem. Cosine theta equals root 2 over 2, then what is theta? And in particular, like, assume that theta is somewhere in the interval from 0 to 2 pi. Because cosine theta equals root 2 over 2 just on its own actually has infinite solutions. And I guess we could write those out as well, but for the sake of what I'm trying to demonstrate, just assume that we want to know for what values of theta in 0 to 2 pi is cosine of theta equal to root 2 over 2. So take a second, pause the video if it's not obvious to you, and answer that yourself. For what values of theta is cosine of theta equal to root 2 over 2? Well, the answers are theta, cosine theta equals root 2 over 2 at theta equals pi over 4. And also, on 0 to 2 pi, at 2 pi minus pi over 4, so 7 pi over 4. Those are the solutions to that. What are the solutions to this? Theta equals cosine inverse of root 2 over 2. You know? The solutions are still related. The solution to that is theta equals pi over 4. Why not 7 pi over 4? Where did that piece go? Because these are kind of like, you know, they're related equations. They're asking a very similar thing. So why does this first one, cosine of theta equals root 2 over 2, why does that have two solutions? Whereas sort of taking the inverse of this exact same thing and saying, oh, theta is cosine inverse of root 2 over 2, that only gives one output, which is pi over 4. Well, the reason is because of how we defined cosine. So remember, we had to, like with all of these trig functions, we had to restrict the domain of the trig function. So like cosine, we had to restrict the domain of cosine in order for it to be one-to-one, so that its inverse was also a function. And that's where it comes from. What is the range of cosine inverse, the cosine inverse function? The range of cosine inverse is 0 to pi. Which of these two values is in that interval from 0 to pi? Only pi over 4. So cosine inverse and all of the inverse trig functions, because they're functions, you give it one input, it produces exactly one output, not two outputs. So that's like the big trap that you have to be aware of when it comes to using inverse cosine, is that you will oftentimes come across a question like this: solve cosine of theta equals root 2 over 2, and you might immediately think, this is the perfect use for the inverse cosine function. And you can get the 7 pi over 4 piece from using the inverse. You just have to do a little bit of thinking. So, and again, think about the unit circle. So here's the unit circle. And what this cosine inverse of root 2 over 2 is saying is that, okay, well, cosine of pi over 4 is root 2 over 2. Pi over 4 is 45 degrees, so it's about right here. Right? Cosine of this is root 2 over 2. But so too is the cosine of this angle, root 2 over 2, taking that same angle and reflecting it over the x-axis. This also has a cosine of root 2 over 2. Right? These both pass through the same x-coordinate, which is what cosine of theta is. On the unit circle, cosine of theta is the x-coordinate. So both pi over 4 and what amounts to, this point is 2 pi minus pi over 4. What is 2 pi minus pi over 4? Well, that's 7 pi over 4. So you've got to be sort of careful and pay attention, right? Because and the solutions are boxed off. So I think that there are two mistakes that can be made. One is that looking at the question, cosine of theta equals root 2 over 2, you immediately think of the inverse function and you only get half of the solutions when there are two solutions. The other problem is remembering that if the problem is stated this way, theta equals cosine inverse of root 2 over 2, there is only one solution because cosine inverse is a function, meaning you give it one input, it produces exactly one output. So just kind of be aware of that. Yeah, so that's kind of like the big caveat. Let's see, another kind of question. I really like these questions too, by the way. This is where cosine inverse or inverse trig functions, they get used also. I really like these kinds of questions. I think that they're really tricky. Let's see if I can make it up off the top of my head. We want to find, let's say, we want to find the cotangent of, say, sine inverse of, what do we want to do? I need to be kind of careful here. X over 1 plus x. How do we solve something like this? Take a second, maybe, pause the video, play around with it. It's how you get good at math, by the way. It's not just by watching somebody else do it and listening to them explain it. You've got to do it yourself. For better or for worse, it's like any other skill. How do we solve something like this? Well, remember, this is how I think about it at least. Inverse trig functions, what is the output of an inverse trig function? Like, what would the output of sine inverse be? The output of sine inverse would be some angle. Let's just give the angle a name. We'll call it theta. We'll say, let theta equal sine inverse of x over 1 plus x. Oops, 1 plus x. Then, this becomes, what is the cotangent of theta? Right? This is just like a way of rewriting it. I'm just kind of simplifying it. I'm saying that I know that this internal piece, sine inverse of x over 1 plus x, that's just some angle. So at the end of the day, all that this big ugly thing is asking me is, what is the cotangent of that angle? Well, let's figure out what that angle is. We know that theta equals sine inverse of x over 1 plus x. I don't know how clear that plus is. My video is kind of small. 1 plus x. So this is in some ways equivalent to saying that the sine of theta equals x over 1 plus x. But relationally, within a triangle, what does sine represent? Sine of theta in a right triangle is the opposite side over the hypotenuse. Opposite over hypotenuse. And we have this direct kind of like correlation, which means that all of this is coming from some diagram, some triangle, some right triangle, where we'll say theta's down here. The side that is opposite of theta has a length of x. The hypotenuse has a length of 1 plus x. So now, here's our theta. And again, at the end of the day, all that this is asking is, what is the cotangent of theta? Well, cotangent, relationally, within a triangle, is the adjacent side over the opposite, right? Cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So we just have to figure out, what is this adjacent side? We already have the opposite side. Let's figure out what the adjacent side is. So I'll call it A. Well, by the Pythagorean theorem, we know that a squared plus x squared equals 1 plus x squared. So it must be the case that a squared is equal to 1 plus x squared minus x squared. So a itself, because we don't want a squared, we want a must be the square root of that. So the square root of this right-hand side, and I'm going to kind of expand it out 1 plus x squared is 1 plus 2x plus x squared, and then we have this minus x squared there. So the x squared pieces cancel. A, the adjacent side, is equal to the square root of 1 plus 2x, or 2x plus 1 is probably how I'm going to rewrite it. So A is the square root of 2x plus 1. All right. And I guess I could have written this as x plus 1 as well, just to stay consistent. Whatever, it doesn't really matter. If I was more compulsive, then I would do something about that. Okay, so what is cotangent of theta then? Cotangent is adjacent root 2x plus 1 over the opposite side, x. And that's the answer. This is the cotangent of the sine inverse of x over 1 plus x. Okay, so kind of a cool application. I really like those problems. They're one of my favorite problems. Right, so that is that. Hopefully I'm not forgetting any little things that I should be mentioning. I don't think I am. If you have any specific questions, let me know. I'll answer them for you.